In this tutorial, we'll understand charge by induction and conduction using three materials: PVC pipe, animal fur, and electroscope. Of course, using 5 scenarios, dividing these 5 scenarios into 16 sections. Let's go over scenario number 1, which is charge by induction. In fact, scenario 1 and scenario 2 will help you understand charge by induction, charge without touch. We also along the way gonna understand conservation of charges. So this is scenario 1. We're gonna call it scenario 1. Let's zoom in. Okay, so let's start scenario 1. Scenario 1, dividing it to 3 sections. We have 3 sections. We're gonna call scenario 1.1, scenario 1.2, scenario 1.3. Scenario 1.1, we have a PVC pipe. Scenario 1.2, we have animal fur. Scenario 1.3, we have electroscope. Scenario 1.1, PVC pipe, proton and electron. Number of proton, number of electron are the same here and same here. So 4 proton, 4 electron, 4 proton, 4 electron, 4 proton, 4 electron. Let's draw a PVC pipe. Let's draw animal fur. Let's draw an electroscope. Let's show that it has same number of electron and proton. Same here. Same here. Okay, so this is scenario, of course, 1. Now let's do scenario 2. Scenario 2, I'm going to divide it in 4 sections. I'm going to call it, this is scenario 2. And I'm going to divide scenario 2 in, of course, 4 sections: 2.1, 2.2, 2.3, 2.4. Let's call it 2.1, scenario 2.1, scenario 2.2, which is PVC, scenario 2.3, which is electroscope, scenario 2.4, which is electroscope. All right. This is after rubbing. After rubbing what? The PVC pipe with the animal fur. What happened to the, of course, PVC pipe? I'm going to draw the PVC pipe. PVC pipe gonna gain electrons. And why? Because electron affinity for PVC pipe is greater than electron affinity for animal fur. Okay. After rubbing, due to triboelectric effect, there would be transfer in charge from animal fur to a PVC pipe. Okay. So let's draw it again. Okay. Okay, so 4 electrons, 4 protons, and let's say 2 electron transfer. From where? From animal fur. So protons 4, electrons 6. So we're gonna do 2 things now. We're first gonna do electroscope. Here is our electroscope, and here is our PVC pipe. make sure it doesn't touch the electroscope. Okay, great. So electroscope is negatively charged. 1, 2, 3, 4, 5, 6. 6. And 1, 2, 3, 4. So this is polarized. And this was like this before. 4 proton, all the 4 proton gonna be here, and all the 4 electron gonna be here. Why is that? Because electron attracts proton and electron repels the electron. So there is a repulsive force between this electron and this electron, pushing them as far as possible, and there is an attractive force between this proton and this electron, making them as close as possible without touch, of course. Okay, now we're going to do scenario 2.4. To do scenario 2.4 and how this is different than this one, scenario 2.3. Scenario 2.3, you have electroscope is very close to the PVC pipe. Now you remove the PVC pipe. So you're going to just draw electroscope. Now, let's show the conservation of charges. Conservation of charges, I have 3 scenarios over here. I have 8 plus 8 plus 8, 24 charges. I have 3 scenarios over here. I have 10. Okay, so 10 plus. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is this one? This is PVC pipe. I did not draw animal far. Let's draw the animal far here. Animal far instead of PVC pipe. That is PVC pipe. So draw animal far. Okay. Animal far has 1, 2, 3, 4 proton, and it lost 2 electrons. To where? To the PVC pipe. So it's no longer have 4 electrons. It has only 2 electrons. So 10 plus 1, 2, 3, 4, 5, 6 plus. Let's look at the electroscope. Electroscope has 1, 2, 3, 4, 5, 6, 7, 8. All right, so 16 plus 8, 24. Okay, so conservation of charges, we show the conservation of charges. Good. This is charged by induction. Now we're going to get to see charge by conduction. Again, we're going to have 2 scenarios, scenario 3 and scenario 4, and we're going to divide them in 7 sections. Scenario 3. Scenario 3, we're going to divide in 1, 2, and 3 section. We're going to call 3.1, 3.2, 3.3. 3.1, I'm going to have animal far. 3.2, I'm going to have PVC pipe. And 3.3, I'm going to have the electroscope. Okay. And I'm going to have 3, 4, scenario 4. I'm going to have 4.1, 4.2, I'm going to have PVC. 4.3, I'm going to have electroscope. 4.4, I'm going to have electroscope. And I'm going to have 5. Can I zoom out? Yeah. So I'm going to have 5, scenario 5. So this is 5.1 and this is 5.2. Okay, so that's pretty much it. So let's show the electron and proton. Plus, minus, plus, minus, plus, minus, plus, minus. Okay, so I have 4 proton, 4 electron. Plus, minus, plus, minus, plus, minus, plus, minus. I have 4 proton, I have 4 electron. Plus, minus, plus, minus, plus, minus, plus, minus. I have 4 proton, 4 electron. You rub it. PBC with far. If you do that, how the far will look like? Well, far will lose the electron. So proton is still the same, but there would be less electron. So proton 4, electron 2. Now you have scenario 4.3, electroscope, and scenario 4.2, PVC pipe, but they touch each other. Where this extra electron, where this 2 extra electron gone? Of course, to the PVC pipe. So it used to have 4 proton, 4 electron. Now it has 2 more electron. This electron gonna attract the proton, and this electron gonna repels the electron over here. But there will be transfer of electron. How many? Let's say 2. Great. So now let's see conservation of energy hold. 8 plus 8 plus 8, 24. 6 plus 2, 3, 4, 5, 6, 7, 8 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 24. Conservation of charges hold. We're going to remove the PVC pipe now. So now electroscope by itself. If you do that, what do you see? 1, 2, 3, 4. 1, 2, 3, 1, 2, 3. We see exactly scenario 4.3. Okay, this is polarized. Now, scenario 5.1 is similar to scenario 4.4. Why is that? Is because, of course, we're going to ground it, but we haven't grounded yet. So it does look like exactly scenario 4.3. Plus minus. No, scenario 4.3. So plus 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 plus. 1, 2, 3, 1, 2, 3. So we're gonna ground it. We're gonna call it charge by grounding. So this is Earth. This is me. This is electroscope. This is scenario 5.2. Plus minus, plus minus, plus minus, plus minus. It happened only if you touch it. So all the electron, extra electron, all how many extra electron? 2 extra electron. Move to all the way to the Earth. However, doesn't make Earth negatively charged because Earth is a reservoir. All right, so this is the idea. Now let's see whether this idea is going to help us solve some of the problem. Okay, so first we're going to do this. We're going to create a table. We're going to call scenario 1. Scenario 1, we have 1.1, 1.2, 1.3. Let's call it here 1.1, 1.2, 1.3. Let's call this one PVC. This is called FAR or something like that. We'll get to that in a second. Scenario 2, 2.1, 2.2, 2.3, 2.4. Scenario 3, 3.1, 3.2, 3.3. Scenario 4, 4.1, 4.2, 4.3, 4.4. Scenario 5, 5.1, 5.2. Scenario 1, 4 electron minus 4 proton, 0 net charge, and this is neutral. So N for neutral. Scenario 2, 4 minus 4, 0, neutral. 4 proton, 4 electron, net charge is 0, so it's neutral. 4 minus 4 is 0, neutral. This is, of course, far. This is far. This is far. This is electroscope. Electroscope. Okay. So 4 minus 2, right? So this is positively charged. 4 minus 6, this is negatively charged. Okay. Now let's see. The electroscope is now 4.4. 4 minus 4 is 0. So it's neutral, but it's polarized. And it's 4 minus 4, which is 0, is neutral, not polarized. 3.1 is 4 minus 4, which is 0, neutral. 4 minus 4, which is 0, neutral. 4 minus 4, which is 0, neutral. 4 minus 1, which is 4 minus 2, positively charged. 4 minus 6, negatively charged. 4 minus 4, neutrally charged. Oh no, this is not neutrally charged. This is, of course, electroscope. This is electroscope, okay. So this is negatively charged, okay. After charge, so some of the charge is going to move there. So this is also negatively charged. This is 4 minus, let's say, 6, so minus 2. So this is negatively charged, and this is yeah, same thing. 4 minus 6 is equal to minus 2. 5 minus 2 is 4 minus 6 is equal to minus 2. All right, so this is polarized. This is also polarized. So this is 4 minus 4, 0. And this is neutral. This is charged by grounding. Let's do this one. Let's fill in the blank. There are 14 blank. You're going to have to write 14 items to fill in those blanks. When you walk across a carpet, electron transfer to your body. From carpet through through your shoe. Due to triboelectric effect. This is charged by conduction. Your body now has a net negative charge. When you reach for a metal doorknob, which is conductor, the excess electrons quickly transfer to knob, especially if it is made of metal. This sudden movement of charge is felt as a shock. A small example of discharge via grounding. And conduction. Doorknob takes all the negative, all the extra. All right, now let's see the demo. I have two electroscope and I have two animal fur, so I'm going to use this animal fur. So I'm going to use this one. So I'm going to do scenario one. Scenario one, I have divided three sections. This one has 4 electrons and protons. This one has 4 electrons and protons, and this one has 4 electrons and protons. Scenario one, 3 sections. 3 sections all together have 24 electrons and protons, and there you go. Charged by induction. What does that mean? Charged with your touch. What happened? This is called triboelectric effect. So the electron will transfer from far to PVC pipe. Why is that? PVC pipe has more electron affinity, meaning that the far will lose electrons and PVC pipe will gain electron. PVC pipe will be negatively charged. So the one edge of the PVC pipe would be negative, and the knob of the electroscope will be positive, and the leg of the electroscope would be negative. So let's take a look. So this guy is negative, all right? This guy is negative. This is negative. So negative, negative repel, and all the positive are on the knob of the electroscope. So if I remove this, what happened? They go back to normal. What does that mean? That means that this electroscope is now back to 1.3, okay? 4 protons, 4 electrons, and it is neutral, not polarized. Great. Now what are you going to do? You're going to do, that was scenario 1 and 2. Now we're going to do scenario 3 and 4. Scenario 3 and 4, we're going to do this. We're going to bring the electroscope. And this is scenario 3. Scenario 3, 8 electrons, protons, 8 electron protons, 8 electron protons, 24 electron and protons. Very good. They all are neutral. Now, to go from scenario 3 to scenario 4, I have to rub the PVC pipe against the animal fur. If I do rub it, then electron going to transfer to PVC pipe from animal fur due to electron affinity. Now this time I'm going to touch it. So all the extra electron transfer to electroscope and went to the leaf. So leaf are repelling each other, okay? Because leaf has extra electron. Okay. Now if I remove the PVC pipe, they're not going to go back to normal. Leaf not going to go back to normal because there are extra electron on the leaf. Okay, so it didn't go back to normal. So what are you going to do now? We're going to charge. We're going to do charge by grounding. So my one end of my foot is on the ground. So this is a shoe. All right, this is shoe, and my foot is on the ground. And the ground going to use me as a wire. So all the extra electron, let's say how much extra electron? Let's say, I don't know, say negative 3.2 times 10 raised to 10 raised to 20, 10 raised to 20 coulombs charge over there. How many extra electrons, we don't know, but all the extra electrons going to go through my body, right, and then they're going to enter the ground. This is called charge by what? Ground. Okay, let's see. All right. So what happened as soon as I as soon as I touch the electroscope, all the extra electrons went to my body, and from my body it moved through the ground, making the electroscope neutral again, +4, -4, making it neutral again. Myself is also neutral because I did not store any extra electron. The ground suck up all the electron. Ground work as a reservoir. Okay, great. Let's say this electroscope has 0 extra electrons. Why is that? Because 4 protons, 4 electrons. Now I'm going to charge it by conduction. Step number 1, I'm going to rub it against each other. This has lots of extra electrons. I'm going to donate some of the electron to the electroscope. This electroscope now is negatively charged. Even if I remove the PVC pipe, you see that this electroscope is negatively charged. These are not 100% flat. So let's say this electroscope is negatively charged. It has some extra electron. How much? I'm not going to tell you. You're going to find out. Okay, how can you find out? Well, N is for extra electron is equal to Q over E. Q is -3.2 times 10 raised to -19 coulomb. E is 1.6 times 10 raised to -19 coulomb. Coulomb cancel. 10 raised to 19, 10 raised to -19 cancel. -19 cancel. How many extra electrons there? 2. Okay, so tomorrow we have a quiz, right? Quiz number 2 for MP3. So this is whatever we discussed last 10-20 minutes. This is going to be in the quiz tomorrow.